Hi guys, welcome to the today's session of design and analysis of algorithms. In today's session, we are going to discuss about mathematical analysis of non-recursive and recursive algorithms with examples. First, we need to know what is a recursive algorithm. What is recursion? The process in which a function calls itself either directly or indirectly is called as recursion. And that function is to be called as recursive function. A function which calls itself either directly or indirectly is to be called as recursion. A recursive function always solves a particular problem by calling a copy of itself and solving smaller subproblems of the original problems. So here, initially it is having a original problem if of size n. In the recursive procedure, it is going to call the same problem with the size n minus 1. Later, it calls a same problem with the size n minus 2. And so on. Like that, it calls. At the end, it calls a problem of the same problem of size 1. It gets the solution for that problem initially. Later on, it gets the solution for the problem size of 2. It gets the solution for the problem size of 3. Like that, it gets the solution for the problem size of n. So here, many more recursive calls can be generated and whenever it required. And it is essential to know that we should provide a certain case in order to terminate the recursion. So if we not given any termination, it goes into the infinite execution. That's why every recursive function should have a termination condition. So we can say that every time the function calls itself with a simpler version of the original problem. Now, what is a recursive algorithm? An algorithm which calls itself either directly or indirectly is to be called as a recursive algorithm. And what is the need of recursive algorithms? We can reduce the length of the code. It makes us easier to read and write the code. And a complex task can be defined with its similar subtasks by using recursion. And what are the properties of recursion? We can do performing of same operations for multiple times with different inputs. At every step, we try to solve the smaller inputs to make the problem very small. And base condition is needed to stop the recursion. Otherwise, it becomes infinite loop. And what are the different types of recursive algorithms? Based on how the function is called, the recursive algorithms are divided into two types, direct recursion and indirect recursion. Direct recursion means a function which calls itself is to be called as direct recursion. And indirect recursion means a function fun called indirect recursive if it calls another function, say funNew, and funNew calls fun directly or indirectly. That is, here you can clearly understand by seeing the example. Here you can see this is a function, direct recursive function. Here I have some code. This function calls again the same function, direct recursive function. So that's why this is to be called as direct recursion. Here, this is the function name. The same function is called within itself, is to be called as, it is recursive procedure. Since the same function is called within the code, it is to be called as direct recursion. Here you can see the example for indirect recursion. Here I have a function named indirect recursive function 1. Here I have some code. Here I called another function 2. Here I called a function indirect recursive function 2. So where this function is defined, here that function is defined. This in turn calls function 1. That is, when I called this function, this automatically will be called in this. So that's why this function is not directly calling itself. This function is calling this one. This in turn calls this one. So that is, this is to be called as indirect recursion. What is the another way of classification of recursive functions? Where the recursive procedure is present in the function or in the algorithm, based on the position, the recursive functions are divided into two types: tailed recursion and non-tailed recursion. A recursive function is to be called as tailed recursive function when the recursive call is the last statement executed in that function. If it is only the last statement executed in the function, then it is to be called as tailed recursion. A function is to be called as non-tailed recursion or head recursion if a function makes a recursive call itself and the recursive calls will be the first statement in the function. It means that there should be no statement or operation is called before the recursive call. You can better understand these tailed and non-tailed recursive functions by seeing these examples. Here you can see the tailed recursion. Here print is the name of the function. So here I have some statements. The last statement executed is the calling of the same function for the less input. Here I call the function for n. Here I call the function for n minus 1. For the less input, for the reduced input, we call the same function. That itself is the last statement, which is to be called as tailed recursion. And here you can see algorithm fun. This is an example for non-tailed recursion. If n greater than 0, fun n minus 1. That is, here we call the function as the first statement for this condition. So this is to be called as non-tailed recursion. And coming to see the examples of recursive algorithms, there are a lot of examples. Finding the factorial, finding the Fibonacci series, finding the sum of first n numbers. All these can be represented using non-recursive functions. And we are going to discuss about a special problem, which is nothing but towers of Hanai for the recursive functions. Towers of Hanai problem is also to be called as the problem of Benares temple or the problem of towers of Brahma, or sometimes it is also to be called as towers or simply a pyramid puzzle. It is the towers of Hanai problem is a mathematical game or a puzzle. Now, what is the statement of this towers of Hanai problem? Towers of Hanai problem consists of 3 towers, which are also to be named as pegs, and n number of disks with various diameters, which can slide onto any tower. These disks are arranged in order of decreasing order of their size, that is ascending order from the top, the smallest at the top, and thus approximately in a canonical shape. So initially, all the disks are arranged in tower 1. Suppose, let us take, here I have, this is tower A, and this is tower B, and this is tower C. Here I have, let us take n is equal to 3. 3 disks are there. Initially, all the disks are arranged in the canonical order, that is decreasing order of their size from bottom to top. Like this, they are arranged initially. Here, the problem is to shift all these n disks from the source tower to the destination tower by using the third tower as an auxiliary tower. Here, the main objective of this towers of Hanai problem is we need to move all the n disks from given source tower to the destination tower by following the simple rules which are mentioned here. The rules are, we can move only one disk at a time, and each move consists of taking a upper disk from one of the pegs and placing it on the top of another peg. That is, we can never place a larger disk on a smaller disk, and no disk should be placed at the top of the smaller disk, which means that the larger diameter disk cannot be placed on a smaller diameter disk. And every time we need to move the upper disk, and only one disk can be moved at a time. By following these three conditions, we need to move the disks which are present on the source tower to the destination tower by using the third as an auxiliary tower. Now, how a recursive procedure can be developed for this problem? Here you can see. Here I have given n number of disks. We given three towers named as A, B, C. Now, I want to take A as source and B as the destination. C can be used as the auxiliary tower. Now, if n is equal to 1, that is, the number of disks are 1, directly I can move the disk from A to B. Since source is A and destination is B, I can move the disk from A to B. Else, if n is not equal to 1, that is, if n is greater than 1, if it may contain 2 disks or 3 disks, we need to call recursively the same procedure for n minus 1. In this case, I need to consider source as A and destination as C, auxiliary as B. And we need to move the disk from A to B. And again, we need to call the towers of Hanai for n minus 1. In that case, C is to be used as source, B is to be used as destination, and A is to be used as the auxiliary tower. Now, how the analysis of this algorithm can be done? Here you can see the analysis of this algorithm. Here, my n is 3. That is, I have given 3 disks. ABC are the 3 towers. Is 3 is equal to 1? No, it is false. So, in the algorithm, we go for else. Now, in that else case, we are calling the algorithm for n minus 1. That is 2. Here, n is 3. So, we are calling algorithm for 2. Again, this recursive procedure is to be solved here. If 2 is 1, we can directly move the disk from source to destination. Else, we are calling towers of Hanai of n minus 1. Here n is 2, n minus 1 means 1. Again, we are calling for this recursive procedure. Here n is equal to 1. Since the condition is true, we can move the disk from A to B directly. So here movement done, A to B directly. Now here the next movement is A to C. Next we are calling this one, this procedure, which moves the disk from source to destination. Here source is B, destination is C. And here this movement comes. And we call this procedure here. And in this procedure, again, we have 2 recursive calls. This is called here and this is called here. And middle we have a movement, direct movement. So these are the order of movements that we need to do to get the solution for this problem. Right? You can see how the disks are moved. This is source, this is destination, and this is auxiliary disk. What is the first move? A to B. Now, initially, let us say this is A. Now, initially, the smaller disk which is present on the top, this can be moved to B. Now, the diagram looks like this. Now, the top of disk is moved here. Now, what is the next movement? A to C. Now, whatever here I have, this should be moved to C. Here, this is the diagram which shows that one. Now, after that, move disk from B to C. Now, here, this disk should be moved to here. After moving this disk here, this becomes the diagram. Now, after that, we need to move from A to B. Whatever the larger disk I have, that should be moved to B. Here, after moving to B, it looks like this. After that, we need to move the disk from C to A. Now, after moving C to A, the diagram looks like this. After that, we need to move from C to B. And after that, we need to move from A to B. Finally, all the disks are arranged onto the tower B. So here you can observe that every time we moved only one disk and never we placed a larger disk on a smaller disk. And we moved all the disks from tower A to tower B. So this is a best example for recursive procedure. I hope that you all understood what is the recursive algorithm, what is the importance of recursive algorithms, and an example for a better example for recursive algorithms. Thank you for listening.